Hello friends, welcome to AI Flux. So today we're talking about monkeys playing Minecraft and what that means for artificial intelligence, science, and understanding our own primates' brains. So the furry guy you're looking at here playing Minecraft with his fingers is actually named Kanzi. He works at a research center with other humans and hominids to help them understand how primate minds work. And recently they tried teaching him Minecraft with the YouTuber Chris DeCow. And before we start this video, definitely go and check out Chris DeCow's video. It's linked below. He's also raising money to donate to the center where Kanzi works. So definitely check them out, donate if you can, and let's get into it. So for me, what was so interesting about this, at least in terms of watching Chris's video and looking at how they managed to introduce new topics to this monkey and show them new things and reinforce what was good, what was bad, and what actually might help them learn faster, is that they're actually striking similarities to how we train machines with AI, specifically with RLHF and some systems that are now used as of 2023. All AI aside, the experience and the experiment of Kanzi playing Minecraft is completely fascinating. And it's really cool to see a non-human biological neural network look at something that is entirely new, not just in terms of things they've done, but in terms of just mental concepts in achieving what they want. Now, of course, when you incentivize machine learning models or AI models, it's a little bit different than giving an ape peanuts, but it's actually quite similar. For instance, if you've played with ChatGPT, and you've realized that it actually performs much better when you appreciate it, or you tell it that it's good, or you give it sort of a time crunch to understand that it has to get something right. These models respond actually in similar ways that primate brains do. And what's really interesting is we've actually been teaching AI to play Minecraft in a number of different ways. We've covered it in 2 different videos on this channel, and there are actually a lot of researchers that have done this. So the parallels are actually quite striking. Some of the training techniques that we use are actually pretty similar to the techniques that these primate trainers used in Chris's video. So to name a few, the ones that jumped out to me were as follows. So the first is what's called in-context reinforcement learning. So for instance, Kanzi gets a fruit or a peanut whenever he hits a marked milestone in the game. This incentivizes him to follow the end-game guides and pick up tasks maybe faster than he would if he was just left to his own devices to see how this game worked. And actually this is important because there's the notion of an interface here with how Kanzi is actually playing Minecraft, and of course that's another really important layer in some of the AI papers that approach teaching AI to play Minecraft. The next one is RLHF, which stands for Reinforcement Learning from Human Feedback. So basically this is feedback or reinforcement learning from a human with their preferences as a technique to reward a machine learning model. And in Kanzi's case, as a primate, he doesn't actually understand much language, but he can see that trainers are cheering him on or giving him occasional hints or signaling to him that he's kind of doing the right thing without necessarily rewarding him right away. So this gives him a really strong signal that he's on the right track. And this is something we're actually still working pretty hard to get AI to do in real time. Imitation learning is another really important one. So basically, this is when the trainers are showing Kanzi just one small demonstration of a simple task or how we might do something, and then actually see him immediately grasp what that is. And for reasons we don't quite understand, this is actually much more efficient than using rewards alone. Some people might say, oh, well, he's just imitating. You just told him to do it. But what's curious is in most cases, even with AI, we see that with imitation learning, the level of increase in capability is actually much more than just the task that has been imitated. It actually seems to reinforce the confidence of the subject, whether it's a primate or an AI, in acquiring new tasks even faster. The last one that really jumped out to me, Kanzi, was a concept called curriculum learning. So the idea here is they start with a very simple environment to gradually teach Kanzi the controls, or like the interface, and at the end, Kanzi is able to navigate complex caves, mazes, and the nether region. The importance here is making the interfaces trained or taught clearly enough that eventually you actually don't have to reinforce the interface itself, which initially getting AI to play Minecraft was actually a huge problem, at least in how the AI understood how think in steps and then how to actually translate those steps into actionable tasks. And above all, Kanzi amazes me because in watching him learn to play Minecraft and interact, it's crazy just how good an ape's vision system is. For instance, Kanzi never saw Minecraft in his life. This is the first time someone put this on the screen he normally interacts with for other training or experiments, and we're pretty sure that his ancestors probably didn't have computers in the wild. So yeah, it's fair to say this is the first time he saw Minecraft, yet he rapidly was able to adapt to Minecraft's texture and physics and environment and physics, which are entirely different than the natural world. This level of generalization is way beyond what our most powerful computer vision models can do today and might even be able to do in the next 2 to 3 years. And we're definitely right in the thick of Moravec's paradox again, which basically means our best AIs are approaching human level on understanding and languages, but are wildly behind even animals in terms of parsing pixels and light. And again, all of Kanzi's work and the video from Chris DeCow's channel all came from researchers at the Ape Initiative, which is a nonprofit organization. And if you think this is cool, definitely go check out their fundraiser on YouTube. Chris has done a great job with this fundraiser, and I definitely recommend that if you can, or if you're into this, that you donate even just a few dollars. So in the meantime, here's how we managed to teach GPT-4 to play Minecraft. Some were more efficient, some used GPT-4, some used fine-tuned LLMs. You can argue either have their trade-offs. I'd like to focus on Voyager, which they describe as a lifelong learning agent that plays Minecraft purely in context, with a consistently improving model how to do this. And I also really like their interaction and their step model for actually modeling thought and decision processes. And it's still really impressive, but at a high level, I think looking at Kanzi and how he learned and looking at AI, I think it's still fair to say that even now, in terms of the energy input, in terms of how adaptively and reactively they're able to play, so just like the speed of play and the rate of improvement, if you're looking at purely in terms of time and skills acquired, I still think apes are better at this than AI. And obviously humans are better at apes than this, but Kanzi managed to do this without really speaking English. And he actually managed to master quite a bit of the game just within the first few hours of play. And if we compare that to GPT-4 with Voyager, clearly this took quite a bit more time to understand. And for those of you who are curious, actually watching Voyager or some of these other LLM agents play Minecraft, it's actually quite slow. Usually most of the videos you're watching them do are sped up quite a bit. So they actually can't play Minecraft in real time. And the way I would sum this up is that Kanji is incredible, and obviously Voyager technologically is quite incredible. But in short, I would say Kanzi's training is a natural way, and that GPT is the alien way. I say natural in that Kanzi's brain is built very similar to humans like ours. And GPT's forebrain is something that we don't really even know how to visualize yet. I'm sure OpenAI has some curious ways of doing this. For instance, you can go onto ChatGPT and you can ask it, show me an image you imagine to be what love looks like. And it might show you something wild that looks like an image of the donut of a black hole. But the Voyager brain is alien, and Kanji's brain is something that's very similar to ours, something of the natural world, but both operating in sort of a neural context to play a game like Minecraft, and understand why you want to use a diamond pickaxe over a wood pickaxe. So I just wanted to showcase this really quick for you guys. I thought it was a really cool comparison of two different kinds of neural networks, biological or synthetic, learning to play a game. And let me know what you think. As always, if you like our content, please like and subscribe. If you would like to rent a really inexpensive GPU and try some of this on your own, definitely check out our discount link to Vast AI below. And as always, we hope you learned something, and we'll see you in the next video.